So here's the last part of problem 4 from the 2011 Form B AB exam. And in this piece, what we want to do is we want to take this function value, so when x is 1, the function value is 2, and we want to determine what the function f is. And what we have to go off of here is we have the derivative of f. So if we start with the derivative and we want to determine the function, we're going to have to do an antiderivative or an indefinite integral. So I'm just going to take the derivative here, and I'm going to toss it into an indefinite integral. Now, the thing that you have to be careful with before taking an antiderivative here is the fact that this is a product, what we're trying to do an indefinite integral or an antiderivative of, and we have no product rule for integration. And so what we're going to need to do is we're going to need to do some algebra that gets rid of that product before applying any of our antiderivative rules. And the algebra is pretty simple. We would just distribute to get rid of the product, and then we'd be looking at 4x to the negative third, and then minus, well, this is x to the first times x to the negative third, so I'm going to add those exponents when I multiply like bases, and that'll give me negative 2 as the exponent on that x. And I want to do this integral with respect to x. I don't have a quotient, a product, or a chain anymore here, so I'm going to be able to go ahead and apply the power rule to take this piece of the antiderivative, and then do another power rule to take this piece of the antiderivative. So when I use the power rule, I'm going to add 1 to this exponent, and that's going to make the new exponent negative 2. And then I'm going to divide by that new exponent. So the first term of my antiderivative is going to look like that. And then I'm going to subtract the antiderivative of this piece. So I'm going to add 1 to that exponent, which will give me x to the negative first. And then I'm going to divide by that exponent. This can definitely be cleaned up a little bit. And the other thing that you cannot forget within this particular question, and any time you're doing an indefinite integral, is the plus c that always arises. Right? When we take the derivative of this to produce f prime, we know the derivative of any constant sitting here is going to be a 0. So we have to account for that constant anytime we do an antiderivative. So this is f of x. Right? F of x is going to be equal to, and I'm going to clean this up a little bit, 4 divided by negative 2 would give me negative 2. And then rather than having it as x to the negative second, I'm going to push that into the denominator across the fraction bar, change the sign on the exponent. And then the value of this fraction is negative since it's a positive divided by a negative, and rather than subtracting a negative, I'm just going to change that to addition. And then I don't want the negative exponent there, so I'm going to rewrite that second piece as 1 over x. There's my plus c. Well, the benefit of having this provided to us is we can actually use it to figure out what our value of c is. This is the x value that produces a function value or a y value of 2. So if we take the y value of 2, toss it here, and then take the function value of 1, take the x value of 1 and put that in place of our x's, we should be able to solve this equation for c. So let's see. This is just going to be a 1 in this denominator, so this first term is just a negative 2. And then that's a plus 1 as that second term. And then the plus c follows that up. And so if I add the 2, that would get me to 4. And if I subtract the 1, that would take me to 3. There's my value of c. So what is f of x? Well, f of x, just like I wrote back here, is going to be negative 2 over x squared plus 1 over x. But rather than plus c, we know the value of c. We got a positive 3 for c. So there is your function f of x that has this as its derivative and also includes this point on the graph.